All right, number 1, 10.3, we have 3 parts. We want to determine the critical values for a right tail test, a left tail test, and a two-tail test. And we are giving our t-distribution. So A says alpha 0.01 level of significance with 15 degrees of freedom. So we're going to go to the table. We're looking for 0.01. Now this table tells us the area in the right, and that's what this table tells us. So 0.01, 15 degrees of freedom is 2.602. 2.602. Positive 2.602. All right, when we do the area in the left, we have to remember symmetry. So this table has symmetry. So whatever, if I want the area to the left, know that that is equal to the area to the right. This would give us a positive value. This would give us a negative value, but the number would be the same. So we're going to find the level of significance, and then sample size n. So remember, degrees of freedom is what this table is based on, and degrees of freedom is n minus 1. So if we have 10 minus 1, we're looking at 9 degrees of freedom. And we got to remember, since we're dealing with left, we want to make the negative. So I'm going to go back to the table. Level of significance was 0.01, 9 degrees of freedom, 2.8, so 2.821, and that's going to be negative 2.821. And then C, we're going to determine the critical value for a two-tailed test, 10% level of significance. So 10%, when we're doing a two-tailed test, we're going to be taking that 10% and dividing it by 2, because it's going to be evenly distributed in the two tails. So if I take 0.10 divided by 2, it's going to be 0.05. So I'm looking for 0.05 area to the right. That's going to be the same 0.05 over here. So 0.5 and 0.5 give me the 10%. So we're given two values. We have 13, so minus 1 is going to be 12 degrees of freedom. So I'm going to go do 0.05, 12 degrees of freedom. That is 1.782, 1.782. And this is positive and negative because we got two tails.